Hello, good people. This is Trockers. Welcome back. Okay, we have a problem on our series in binomial expansion. It's from ZIMSEC November 2025, paper 2. All right, it was number 8. First part, the nth term of a series is given by 4 to the n minus 4 plus 6n. Find the sum of the first n terms. Then B item 1, find Maclaurin series for f of x equal to 1 minus x to the negative 1 up to and including the term in x to the fourth. Then find the expansion of that up to and including the term in x squared. Hence, find the set of values of x for which the expansion in item 3 is valid. I mean, in item 2 here is valid. Okay, so guys, let's get started. Right, so first part, we are just given this series here, right? So we are given the series 4 to the n. So we are given the series 4 to the n minus 4 plus 6n. We need to find the sum of the first n terms. All right, so to find the sum of the first n terms, we are going to introduce the summation series here from n equal to 1 up to n of 4 to the n minus 4 plus 6n. All right, so here, okay, so this is what we are going to do. We're going to separate this from n is equals to 1 up to n of 4 to the n minus 4 plus 6 summation from n is equal to 1 up to n of n terms. Right, so as we can see, right, as we can see here, if we try to plug in when n is 1, let me see what we are getting. So when n is, if you plug in 1 here, it's going to be 4 to the negative 3. Right, if we which is just 1 over 4 to the third power. When n is 2, it's going to be 4 to the negative 2, which is 1 over 4 to the second power, right? Then when n is 3, it's going to be 4 to the negative 1, which is 1 over 4, right? And here we are actually seeing that, okay, so the first term is 1 over 4 to the third power, right? The first term here is our first term, which is our a. So our a is equal to 1 over 4 cubed, which is 1 over 64. Then our common ratio now, our common ratio is equal to just 4, right? So our common ratio is 4 because we are multiplying by 4 here. So if we keep multiplying by 4, we are going to get our common ratio. So this is now a geometric progression with first term a and the ratio 4. And these are some of the first n terms. So we are going to use n over 2 of n plus 1, right, for sum of first n terms, right? So here we are going to use, since r is greater than 4, we are going to use a r to the n minus 1 over r minus 1. So that's the formula which we are going to use for this series. So now let's do it this way. So it's going to be, so we are just saying a is now 1 over 4 cubed, right? Then r is 4 to the n minus 1 over 4 minus 1 plus we had a 6 here, then it's n over 2 of n plus 1, right? So if we simplify here, we are getting 1 over 64 times 1 over 3. Then we have 4 to the n minus 1 plus this is 3 n of n plus 1, right? Which simplifies to what? 64 times 3. 64 times 3 is 192. So 1 over 192, right? 4 to the n minus 1 plus 3n squared plus 3n, right? I believe we can leave it like that. So this, because we cannot combine those two. So this is the sum of the first n terms of that given series. Right, so we are done with part A. Let's move on to part B of this question. So on part B, it was Maclaurin. So part B of the question is we need to find the Maclaurin of 1 minus x to the negative 1. All right, so remember, if it's up to x to the fourth, we have to differentiate 4 times. So in this case, if our f of x is equal to 1 minus x to the negative 1, so our first derivative, we bring down the power, we multiply by that, then we subtract 1 from the power. So it's just 1 minus x to the negative 2, right? Then second derivative, we are going to bring down the negative 2 times the negative 1, then we subtract 1, right? Which is just 2 of 1 minus x to the negative 3. Then our third derivative, we are going to bring down, then it's 1 minus x to the negative 4, right? Which is equal to 6 of 1 minus x to the negative 4, right? Then our fourth derivative is equal to 6 times negative 4 times negative 1, 1 minus x to the negative 5, right? Which is just 24, 1 minus x to the negative 5. Okay, so here we can rewrite this as 1 over 1 minus x. Here we can rewrite this as 1 over 1 minus x squared. Here we can rewrite this as 2 over 1 minus x cubed. And here we can rewrite as 6 over 1 minus x to the fourth power, and here it's 24 over 1 minus x to the fifth power. Right, since this is Maclaurin, we also need to evaluate at 0. So we now need to find f of 0, f prime of c at 0, f prime prime at 0, and the last one here at 0. Right, so if we plug in 0 here, 1 minus 0 is 1, so it's just 24, right? Okay, so if we plug in 0 there, it's 6. If we plug in 0 there, it's 2. If you plug in 0 there, it's 1, and on the other one, it's 1 as well. All right, so both of these are 1s. Right, so once we have this, we know that the Maclaurin, it states that f of x is equal to f of 0 plus f prime at 0 x plus f prime prime at 0 x squared over 2 factorial plus f prime prime at 0 x cubed over 3 factorial plus f prime 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 at 0 x to the fourth over 4 factorial. So we're just plugging in the numbers, so it's just 1 plus x plus this is 2 over 2x squared plus 6 over 3 times 2x cubed plus 24 x to the fourth over 4 times 3 times 2 times 1. Right, so here it is just 1 plus x squared, right, plus x cubed plus x to the fourth. So this is the Maclaurin series for that function up to and including the term in x to the fourth. Right, so now we are moving on to item number 2, right, which is the binomial expansion. So B item number 2. So on B item 2, right, we want to expand here up to and including the term in x squared. Okay, so now let's come back here. So we want to expand 9 minus x to the 3 over 2, times 1 plus 3x to the 3 over 2. Right. So first, I want us to use this 1 plus x to the n is equal to 1 plus nx plus n minus 1 x squared over 2 factorial. So I'm going to expand this separately, then we combine, making sure that we get rid of any powers higher than 2. Right. So if I start with this one, 9 minus x to the 3 over 2, we can rewrite this as 9 to the 3 over 2 here. Okay. So it's 9 to the 3 over 2. So we have 1 minus x over 9 to the 3 over 2. So which is just square root of 9 to the third power. Here it's 27. Right. When I say 9 to the 3 over 2, it is the same as saying square root of 9 cubed, which is just 3 cubed, which is 27. Right. So here it's 1 plus n is 3 over 2 minus x over 9 plus n 3 over 2 minus 1, which is 1/2. Then x minus x over 9 squared over 2 times 1, right? Which is equal to 27, 1 minus 3. So it's 1 minus x over 6, right? Then plus, okay, if I simplify here, it's going to be 4. So 3 over 4 times this, which is 3 over 8, right? Times 1 over 81. Okay, so what do we get there? It's going to be plus 3 over, it's going to be plus 3 over, okay, so 3 divided by 81 times 8. So it's going to be 1 over 216, right? So here it's 1 over 216 x squared, right? So if we plug in 27, this becomes 27, right? Okay, so it's going to be 27 times 1 over 6. So it's going to be 27 times 1 over 6. It's going to be negative 9 over 2x. Then 27 times 1 over 216, right? It's 8, so plus 1 over 8x squared. Okay, so this is the what? This is the first one. Then the second one is more direct, all right? So the second one is just 1 plus 3x to the 3 over 2. So it's just 1 plus nx plus n minus 1 x squared over 2 factorial. So this is 1 plus 9 over 2x plus, okay, this is 4. So it's here it's 2 times 2, 4 times 2, 8. So it's 3 over 8 times 9. That's 27. So plus 27 over 8 x squared. Okay, so we have this one here. Okay, let me double check something here. That's good because that's 81. Okay, so from there now, since it was the product of these two, 9 minus x to the 3 over 2 times 1 plus 3x to the 3 over 2, we are just multiplying these two. We are multiplying 27 minus 9 over 2x plus 1 over 8x squared, right, times 1 plus 9 over 2x plus 27 over 8x squared, right? Okay, so when multiplying these now, okay, we start with 27, so 27, it multiplies everything, so it's going to be 27 plus, so 27 times 9 over 2, right? So it's plus 243 over 2x then plus 27 times 27 over 8, so plus 729 over 8x squared. We are done with this. Now let's multiply with that. This and that minus 9 over 2x. This and that, it's minus 81 over 4x squared. So when we are done with this, we have to multiply this by that. So plus 1 over 8x squared. Okay, other powers are now higher powers. So when we simplify here, we have got 27, then this and that. So 243 over 2. 243 over 2 minus 9 over 2. I'm getting just 117. Okay, plus 117x. 243 over 2 minus 9 over 2. Okay, so I'm getting 117. Then I've got this one, right? So I've got 729 over 8 minus 81 over 4, right? Plus 1 over 8, right? I'm getting 71 plus 71 x squared, right? So this is the expansion, guys, up to and including the term in x squared, right? Then now on the last part, it's about validity range. So we want to state the set of values of x for which this expansion here is valid. All right, so what we simply do is we're going to have two set of values here. Then we find the common one. So for 9 minus x to the 3 over 2, right? So when we are expanding, when x is rational here or a negative, the expansion is valid up to a certain limit. So here it simply means the modulus of x should be less than 9. So x should be less than 9, which is just from negative 9 x to 9. Then another one, which is 1 plus 3x, right, to the 3 of, 1 plus 3x here to the 3 over 2. It simply means absolute of 3x is less than 1. So absolute of x is less than a third. So from minus 1 over 3 less than x less than 1/3. So when comparing these two, right, obviously this one will fit into that, but this will never fit into this. So therefore, the validity range will just be from negative 1 over 3 less than x less than a third, or simply absolute of x is less than a third. So this will be the set of values of x for which that expansion is valid. So guys, with that being said, signing out.